Namaste. Today in this video we'll be discussing about statical reasoning. Okay, in previous video we have discussed about the uncertainty in reasoning, and which includes the probability. Yes, we have discussed about the probability and some of the probability theorem as well as some of the parameters used in probability. Okay, and in this video we'll be discussing about statical reasoning. Okay, statical reasoning includes the belief network. Okay, there are several techniques that can be used to augment knowledge representation technique with statistical measures that describes level of evidence and belief. An important goal for many evidence as the system goes along and to modify its behavior. We need a statistical theory of evidence. Bayesian statistics is such a theory of which stress the conditional probability as fundamental notation. So we'll be discussing about Bayesian network. Okay, so we'll be discussing about Bayesian network. So it is also symbolized as Bn. Bayesian network is also known as belief network. They are the graphical structure which are used to represent knowledge about an uncertain domain, where each in the graph represent a random variable, while each, EDG, each between node represent probabilistic dependencies among the corresponding random variable. The conditional dependencies in a graph is estimated by using non-statical and computational method. So let us consider an example. Okay, let us consider an example of certain area of Bhaktapur which can detect earthquake. Okay, which can detect earthquake and fire. Okay, and it insulates the dome. Then Suraj and Sanskriti be the call operator. Okay, and its graph can be represented as, there is alarm also. Alarm. Okay, here is Suraj. Okay, here is Sanskriti. So this is an scenario which we are going to concern. So let us consider probability for each. Okay, each. So there is probability of fire, PF. Let us it be 0.001 for PF. Okay, for earthquake, PE. Let us suppose that it is also 0.001, and probability of fire and earthquake. Okay, we construct a dependency table. So probability of alarm, that is when fire and earthquake occurs, the alarm, the probability of ringing alarm is, if both occur, both is true, then it is 0.99. If fire occurs but earthquake does not occur, that is 0.94. Okay, if fire does not occur but earthquake occurs, then alarm, the probability of alarm is 0.29. And if both does not occur, then the probability is 0.01. Okay, this is the probability table included in alarm. And if alarm rings, then the probability of Suraj to ring the call, that means call operator to inform, let it suppose as probability of D. If true, then let us suppose as the probability is 0.7, and if false, the probability is 0.01. Okay, so Sanskriti, for the case of Sanskriti, let us suppose that if alarm rings, then C has the, okay, let us consider as C for her. So if alarm rings, then the probability is 0.7. Okay, let us consider as 0.8, somehow greater. So next one is probability of, if false, then 0.0. Let's just consider as 0.03. So this is the probability in each node. This is node, okay, this is each. So this graph explains that the probability of occurrence of fire is 0.001, the probability of occurrence of earthquake is 0.001, and the probability of ringing alarm when both earthquake and fire occurs is 0.99, and if fire occurs but earthquake does not occur, then that is probability is 0.94. Similarly, okay, and for case of Suroj and Sanskriti, the probability of calling to the order friends is 0.7, 0.01, 0.8, and 0.03. Okay, so we'll be solving this problem. So retrieving the probability from the conditional distribution, that is P x1 x2 x3 ... xn is equals to pi, that is product, okay, product of P x I equals to 1 to n parent of x1. Okay, this is the formula. So let us consider an example. Okay, probability of C and D and A and not F and not E. So that is probability of C and D and A and not F and not E. That means probability of C, yes, okay, C true, D true, A true, fire is false, and earthquake is false. So that can be expressed as probability of C slash A into probability of D slash A into, okay, this is A. For alarm we have to take the condition of F and E because this is dependent, yes. So that is F and A, F and E both are false. That means fire and earthquake is false, then probability is 0.01. That is probability of A when not F and not E. Okay, so probability of CA, okay, CA is 0.8 into DA, that is 0.7, and into that of both are false is 0.01. Okay, what will its value? Sorry, we have to calculate. Oh, sorry, we have forgotten for F and E also. So that of not F is probability of not F is, if F is true, then it is 0.001. So not F is 1 minus 0.001 is 0.999. Yes, sorry, and that of earthquake is 0.999. Yes, so it is 0.999 square. So please calculate it. So in this way we have calculated the probability. Okay, so in next video we will be discussing about case-based reasoning. Okay, and please solve some order problem by using Bayesian network. Thank you and bye bye.